So hello everyone. Today we're going to talk about great practices for Retrieval Augmented Generation when building a product build something in production. So thanks to the AWS guy for the great Gen AI introduction. So now you all know what RAG is. But basically it's like building any AI product. There is like a long distance from the POC to an actual product that brings value to users. So it's what we'll see today. A few words about myself. So as Matt said it, and as you may have guessed it from my accent, I'm French. I'm working at Hikari. It's a French startup from the Theodo Group, which specializes in developing data engineering and data science products for the clients. And before that, I played a bit with optical character recognition at another startup called Realytics. So just a few relevant experience on vector databases and GenAI I have. So I did a project involving detecting objects in videos and matching them to a large set of objects with Milverse. One which will be like actually the one we'll discuss the most today, which is a semantic search engine, so RAG, for our Notion and HubSpot. I'm currently working in a project for deduplicating adverts using Qdurant. And I wrote a couple of articles on vector databases and open source versus closed source LLMs. And I did some related talks at PyData and at the iterating meetup. So after this quick introduction, let's see what RAG actually are. So as I told you, the AWS guy gave you a quick introduction, but let's go into a bit more depth to see how they work. So basically, you have a lot of documents, let's say a Notion, a Confluence, PowerPoints, anything. And your users are basically struggling to find the information they need. So you can build a RAG, which allow your documents to be queried with natural language. And now for your user happy because they can find the information they need by talking to your RAG like a human being. So this is an example of Hikari, the RAG we developed at Theodo Group. We named it Hikari because it's always nice to give it a name. Turns out to be a Japanese beer, but it's fine. So we integrate it through Slack to make it easier. So let's say we ask it like which linter is recommended by Hikari for Python. It will start by answering fairly quickly with just the sources, because some people just need the sources. They actually don't care about the answers generated. So here it says for Python, it recommends rough or MyPy and black for formatting. So it's just tools for Python to make your code nicer. And then you can convert with it and say, like, let's say, are there any other quality tools recommended? And then it would just be like, just try to say something because this question, is just very vague, and it will just talk about, I can maybe make it a bit bigger, like a CVAT for labeling, or another tool I don't know, which is SiteChecker for SEO. So this is what we build, and basically today's talk is going to be like some feedback, some stuff we learned while building this product. So how RAG works? So first you have your documents. So sorry for the very little text, you don't actually have to read it. You have documents, and you're going to split it into chunks. So chunks are just a small portion of text. So you're just trying to split it into paragraphs and stuff that actually holds into the model which will generate the embeddings. And basically, you try to put some paragraphs which are semantically similar and which are communicating the same ID, so that it will make the embeddings and the representation better. So we just talked about embeddings, and embedding is actually a vectorial representation of each chunk. So it's a fixed size vector which contains a semantic representation of what the chunk actually contains. And then you put all of that in a vector store. So as the AWS guy told you, so you all know what a vector store is. So it's just a database which is made to contain vectors and make them easily searchable. And now your user will be able to, Your user will be able to formulate a query, like a question, the same model which was used to create the vectors for the chunks will be used to create a vector for your question, and this vector will be compared to all the other vectors to actually retrieve the most similar vectors and hence the most similar chunks or documents depending on how you did your embeddings. And from these few documents, you can put it to your large language model, so like Anthropic or Claude or OpenAI or anything, and it will generate an answer. So now you all know how RAG works. So we see good practices to make it actually work in production and bring value to your users. So actually, I'm going to try to make the screen bigger. I don't know why it's like this, much bigger like this, much better. So first, when you start building a RAG, it's good to know there are a lot of tools online, open source, which can be used to get started with RAG. The most famous one is probably LangChain, which you probably all heard about, which is a library which is quite nice to get started with LLMs and build POCs, build proof of concept projects. Another project is Quiver, which allows you to build a RAG and you don't have to be a tech person. It just provides you with the database, the front end, etc. So you can deploy it without having to code at all. And you just drag and drop your documents. Another one, which is a bit less famous but quite nice, is Dancer, which allows you to connect to different APIs like Slack, etc., to give you results, and also integrates a lot of sources like Confluence, Notion, etc., so allow you to like scrap all these sources. The one we used was LangChain because it was the only one available at the time. So this is how we started building our RAG. And when you want to build a RAG, you remember a key part of it is a vector database. And you basically have two kinds of vector databases. The first one is dedicated vector databases. So there are tools which are built for searching documents. It's the only thing that they do. And the other one are general purpose databases, which implemented vector search capabilities, like PostgreSQL, which can integrate with all the AWS, like RDS, etc., etc. And basically, the dedicated vector databases are generally faster, but it only really makes a difference when you start dealing with a large number of vectors. And it turned out that when people build RAGs, they usually don't deal with that many vectors. Sometimes they do. So really, before choosing your database, really think about, do I need that many vectors or no? Because if you start with the PostgreSQL, then you can use it as a normal database as well. So it will be much easier to use, and it will really simplify your stack. This does not mean you should, if you have more vectors than that, you shouldn't use PostgreSQL or stuff like this. It just means we may wonder what is a good choice then. All these vector databases, they all raised a lot of money. So they can now all provide features, which is very good if you have to kick off a RAG project. And some of these DBs, like Qdrant or Wave8, they really is experimental iterations because they can be used as a disk file using the same clients. So it really makes it easier because you use the same tool both for your experiments and for the tool you have in production. So if you want more information about this, I'll put the QR code at the end. But I made an article about how to choose a database, your vector database, so you will have many more details about all of that. So now you got started with your RAG. You have a proof of concept, you have a vector database. Now you need to ensure your information is up to date. Because your user will continuously interact with your documents. They will delete them. They will create new ones. They will also update some. And all the libraries I showed you, they do not actually implement automatic updates of the vector database. So it can be very deceiving or frustrating for users to know that they interact with potentially outdated information, and it will be very bad for adoption. So you basically need to implement an automated workflow to handle all of these changes. And I recommend following the good data engineering practices. So when you build this workflow, as I will show in a sec, split into tasks, because it will really ease debugging, analysis, alerting. Because if you have just one big thing, it will really make all of this much harder. So what we used to build our tool is Airflow, which, as you can see, is really split into tasks, where we first try to identify which documents have changed, then we download them, then we identify empty documents. So this is really specific to our pipeline because it turns out a lot of our documents are empty and we don't want to recommend them to the users. We create chunks, so we split our documents, we compute the embeddings, and we put all of these embeddings into our vector database. So really splitting all these tasks really make it easy when we have a bug to know why it happens and to act fast. Now all your information is up to date. You have your tool started. So you now need to, you get your first users. You now need to collect and analyze user inputs. So user interact with your RAG, and you collect all the prompt and answers they do. It may seem obvious, but not all people do it. And it will allow you to do like very generic things like monitoring usage, monitoring retention. Are people actually using your tool, or is it just something fancy that nobody care about? Ensure the tool is used correctly as well. For instance, our documentation is both in French and in English. So we found out that people requesting it in English, when people requested it in English, it was working much better. So we just provided guidelines asking people to ask questions in English. Identify user needs and generate new ideas. For instance, basically, we're a startup from the Theodo Group, and which is split into a lot of startups, and each startup has its own workspace. And what we found is that people were generally asking questions about their startups, and so we just made a simple filter in the vector database to like when someone mentions Hikari or Aleos. It only returns documents from the startup. And we use user question when iterating, so this kind of allows to change with the next part. So like then you will start to iterate on your pipeline to make it better, to start create custom rules, etc. And all this prompt is a gold mine to basically have something to iterate from. So now you want to leverage your analysis to iterate. So some kind of iterations you can do is customize your prompt. So all your documents will go into a prompt to find the answer you want. You may also provide information about your company, about anything the tool should know, etc., etc. I put a little warning, be careful with chains. So chains is just asking, doing a prompt to extract some information, then doing something else, so asking repetitively the AI to do something. And the thing is that you may lose information from one step to another. For instance, a common thing to do for RAG is to first formulate a first prompt to extract information from each chunk, and then with all this information, answer your question. But the thing is that we found out you lose a lot of information in the process, and if you just do a single prompt with all your chunks, I mean all the most similar chunks, the answer will be much more accurate. So you may also want to try other models to improve chunking, so find better rules from chunking, better clean your chunks to better communicate the intent to both the retrieval model and the LLM later. And add custom rules like the workspace filtering I just mentioned. Identify where is the bottleneck. So you have two parts in your pipeline, retrieval and generation. And for instance, if your retrieval is not working well, then your generation part won't be able to work well because it won't have anything to work with. So identify where is your bottleneck to know what to iterate. For Hikari, we use DVC, which is a great techno, it's like Git, but for data. It allows to version your data, to orchestrate your pipelines. It's a very, very useful tool. And so we use this to iterate for Hikari. Streamlight is your best friend. So Streamlight is a tool to easily visualize your data with Python. So if, like me, you're very bad at web development, but you still want to do some dashboards, it's the tool for you. You can do some dashboard in a few clicks. Why do you need Streamlight? Because automatic evaluation is hard with closed source APIs like OpenAI, for instance. So it does not provide what the model exactly returns, but rather a sampled answer. And so you cannot work with that to do an automatic evaluation. I won't go into too many details about that because it's a bit more complex, but it's just good to know. So when you can't really automatically evaluate your model, you have to do a lot of visualization. So here's an example of a dashboard we built. We'll zoom a bit into it in a second, no worries. It's very easy to build dashboard like this, so you can repeat it yourself as well. So the idea is to have here the question a user asked to Hikari. So when you scroll down, you have all the questions. So for instance, he asked, where can I find information about the Theodo blog? Here is the answer that was provided in live by Hikari, and the sources returned. So as he said, just a very quick answer saying the Theodo blog can be found here. And we are trying to iterate on our model, so we're trying something new. And this something new is saying that for that prompt, so it's a much more complex answer, so it really depends on do you like it or not. So it allows you to know that now you can see it side by side, and it gives you a first idea of whether it's good or no. And then the next step is really to do like A/B evaluation, where people don't actually know which answer comes from which model, and they just click to select which one is best, and then you can get some metrics. It's also good to be able to visualize the chunk behind it, so just add an additional button to basically retrieve what did the chunk contain, because it may not be the whole document behind the link. So you started iterating, improving your pipeline, etc. And now you may want to consider using an open source model because it provides a lot of advantages, like better control and customization. It's really about the idea when you don't use a closed source APIs, you really have access to the tokens that directly get out of the model, the probability distribution of these tokens, and you can really play with them to do some more advanced stuff. So this more advanced stuff involve automatic evaluation. It ensures data privacy since you're controlling everything. We have a lot of clients coming to us saying they don't want to use OpenAI because they are too scared about data privacy. You can fine-tune to improve performance. You can also fine-tune now closed source APIs to improve performance, so it's not really a factor to distinguish them, but it's still good to know, because most open source models are foundation models, like Mistral AI or Llama 7B, so they are usually not the best ones without fine-tuning them. And as I just said, there are recent releases of very performance open source models like Mistral 7B or Llama V2. And if you have an intensive usage, because you don't pay per call, or it's more like a fixed cost, it will be cheaper overall. But you really need to have an intensive usage, because otherwise it will be much more expensive. The disadvantages of open source models, currently GPT-4 outperform all open source models. So if you want to get started quickly, it's better to use it. There are also some very performant models accessible with AWS Bedrocks. And it will be significantly more expensive than Bedrock on OpenAI to use open source models if you only use them a few times, if you only use your RAG a few times a day. You really need to make like, let's say 300 calls a day at least to make it less expensive. Again, there is another article if you want to dig more about it. I'll put the QR code at the end. And to finish this presentation, just a few words on like high-level product considerations. So as I told you at the beginning, we have two sources. The first one is HubSpot, and the second one is Notion. And it's two really different kind of sources, and people using them may not want to combine them. Like when you ask a question to Notion or when you ask a question to HubSpot, it's really for a different use case. So there is no point combining them. I feel I mean, I saw a lot of people actually wanting to do like fancy stuff and trying to combine as many sources as they could. It's not always worth it. Try to think about like what actually brings value to your users. You want to aim for your RAG to become the go-to search tool. You don't want users to have to wonder every time, should I use the RAG, or is it a simple search and I can use the Notion search or the HubSpot search, etc. And when it becomes the go-to tool, you'll notice that most requests are easy. And so it's just, when requests are easy, people don't care about the generated answer. They just want the related document to make it faster. Like they don't want to wait 10 seconds every time. So if you remember from this example, the documents retrieved took a couple seconds to arrive, while the generated answer can take a very long time to arrive. So really return the top K documents first, so that if your users don't care about the generated answer, they can just click on it and don't have to wait for the generated answer. And some classic AI product considerations as well, which are not specific to generative AI, but more generally to AI as a whole, is beta test with a small set of users. I worked on product which went to productions way too early, and as a result, the users were deceived, and then they never wanted to use the tool again because they don't want it to bother. So just when you beta test, keep a small set of users, and when you're sure your product, your RAG is ready, then release it to all the users you want. Do not add again another tool to your stack. You may work in companies with like a lot of tools. Mostly if you work in startups, we love adding a lot of tools everywhere. So if you integrate to existing tools, as we integrated with Slack, it will really favorize adoption. And of course, retrieve feedbacks. So it can be automatically, as you may see in OpenAI, when you can put a thumb up or a thumb down on your request, or manually by just asking questions to your users. So both are very valuable. So as a conclusion, so we started with LangChain to build a POC using Qdront as a vector database. Because we have a lot of documents in our Notion, so about a few 100,000. We actually write a lot in it. Divided into chunks, it makes even more documents. We could actually have used a PostgreSQL, which I think would have been a better choice, but it was the first time using this techno. We really wanted to try it. So it was also a choice we made to just try this new techno, which I have to admit was not the most pragmatic choice, but it works very well. Apache Airflow to orchestrate our pipelines to make sure our documents were always up to date. Then we collected user feedbacks to make sure everything was right. We used DVC to iterate. Used Streamlight to see what actually happened and visualize our experiments. And considered high-level product considerations. Final word I want to say is to point out the value proposition of RAG. It's really to allow users to retrieve trustful information faster and or better than before. So before building a RAG, make sure your users actually need it. They actually need better information or faster information. And before releasing your RAG, make sure the information is trustful. So it's all for me. Thank you very much. And here are 2 QR codes for the articles I mentioned.
That was very good, thank you.
Thank you.
Will we be able to have the slides, please?
Yes, why not?
The recordings will be out sometime in the next 2 weeks.
Okay, thank you.
All right, go for it.
Me. Thank you very much. I've actually used your blog, so I didn't realise it was you, so thank you for those as well.
Thank you.
One couple of questions for me, but I'm just going to pick on one. Have you used anything like Cache GPT to try and optimize like inference by?
I'm not sure what Cache GPT is.
It embeds similar questions that are passed to your QA system.
Is it like an open source tool?
Yes, yeah. So that you can pull, you don't waste time querying similar queries, if that makes sense.
If it's about wasting time, I don't know the tool, so I cannot really answer accurately. But if it's about wasting time, the vector databases are very fast, so it's not really a problem. And the second thing is that we want to return, let's say, top 5 most similar documents. And sometimes we have a lot of like duplicated contents because Notion works with a lot of copy-pastes. So we just do a bit of fuzzy matching where it's very fast, so we do it at inference. And if it returns documents which are very similar, not semantically, but really word by word, like with fuzzy matching, we just remove them. And so let's say we return the top 15, remove some, and return top 5.
So you were talking about chunking up documents for embeddings in the beginning.
Yeah.
Like, how do you decide how to chunk them up?
That's the question everybody wonders. So basically, you need, the ideal thing would be to have a model which will decide what to chunk, but it's more advanced stuff, and you don't really want to go into it. You want to find a general rule. For instance, we found out that for Notion, the general rule was like when someone was going into a new header, it seemed like a new paragraph which was semantically different from the rest, but in each chunk, we appended all the metadata of the page, the title. We did not do it yet, but we want to also add the path, so where it is in the tree, and this kind of information to like provide it as many information as possible. And the thing is that the smaller is your chunk, then the faster your generation will be then, because it will use less content in the prompt.
Cool, thank you.
You mentioned that the model performed better in English than in French. Did you play around with any translation tools to see if you could take French and translate it to English?
We did not bother with it because Oh, you mean translate? Okay, so we could have done it, but the thing is that we may lose information as well. We have some very specific way of talking, I'd say, which are a bit weird, which is why it's not working very well. But it would have been one way to do it, but it then adds another step to the pipeline. And if you directly ask people to speak in English, I think most French people in our company, or I think all of them, can formulate the question in English, so it was working well. But it would have been an idea, yes.
Can we implement for update or something, or we can put a group of user to restrict to access to update or something like that in this role?
Yeah, I mean, it's custom. Like, I think it's not related to GenAI anymore then. You can just implement custom rules, and I think the best way will be to work with metadata. Like in your vector database, you can, each vectors, you can put metadata next to it, and you could put like some metadata related to like level of access, etc. And then when you make a query, you can add some filterings, saying, let's say, all right, this user is making the query, so it can only have the vectors where the level of security is 1. Nice. Yeah.
Speaking of metadata, did you find issues at all with your data quality in the terms of, was there ever assumed context? So when the user asks a question, the actual document that has the relevant data might have not, because if the document was made without, for example, this use case in mind, they may have assumed context in that document that makes it difficult to match.
So if I understand your question well, is that like, is the model responding not with the documents but by itself? Or was it not your question?
No.
Sorry, can you repeat it?
Essentially, if the user asks something and it's doing a match, right, it's comparing against the document, but
Yes.
the document that's relevant might not have the keywords or enough similarity.
Yes.
How do you overcome that?
So there are 2 ways to do it. So you can filter, so you have a similarity threshold. So you can just put a threshold for that. But then you have to find the right threshold, etc. We did not implement it actually. But what we told our generation model to do is just to say, I did not find any relevant information. And so since it's only a few tokens, it's very fast to output. So like when the generative model doesn't know, maybe I can try to make a quick demo. So if I ask, what do you know about last Monday barbecue? If it outputs, I'm not sure barbecue is spelled like this.
You missed a no.
What?
What do you know?
What do you know? Yes. And I really hope it's going to say I don't know, but sometimes, so it outputs documents. No, it outputs documents because I did not filter, I did not put any similarity threshold, but then it really quickly say, I did not find any relevant information. Can you please provide me with more context? Or if,
The right spelling, maybe barbecue as CUE.
yeah, but I'm not sure. I think even if we put theory, I think it's very good at understanding mistakes in words. So.
With that context example and the chaining, would you be able to say to it,
Sorry, I did not know.
with the context example of the chaining,
Yeah.
to say to it, once you find a relative snippet or chunk, go review all the relevant chunks and gather a better understanding, or is that would be pushing it too far? Because when I ask the question, it finds a relevant document, then you split the chunks. It can then sort of look over those chunks to develop a better understanding.
So what you're saying, so I'm retrieving some chunks, and then you say like retrieving more chunks, and then asking a first prompt to extract information?
Yeah.
So it's what I tried to explain, but I may have been confusing, is that this is a classic way like to do RAG, like you see it implemented like this in LangChain, for instance. But what we found out doing that is that in this step of pre-extracting information, we are losing a lot of information actually. And then the final answer was quite bad. So it's actually better to use less chunks, but put them as a whole in your, I mean, it's what we found out at least for a specific use case. It might be completely different for different use case.
Yes, I'm curious.
Yes? Oh, sorry, I was looking at your friend behind you, but you can go. Okay, go first.
Okay, so in Bing Chat, when they reply, they actually give you links to the pages that were used.
Yes.
And they do it inline, so they say for every sentence in the generated content, they say it came from this document, or it's
Yes.
pointed to that document. Do you know how to implement that? Because
Yeah, it's just about the prompts. So if you, if I show you, like, yeah, here, you have a section here which is filtered pages, which comes out at the same time. Oh, sorry. I thought I could make it faster. So which linter is recommended by Hikari. So it first outputs the similar sources, and then you see a section filtered pages that comes out at the same time as the generated answer. It's just because we ask it which sources from these 5 sources did you use to generate your answer. But we could, and so we managed to separate it, but we could also tell the model to say, all right, after each answer, cite your source. So it's just about the prompt.
Last one.
So you mentioned pros and cons about the OS open source model.
Yes.
You had a point there about automatic evaluation. What is that and how does it work?
I'll try to be as concise as I can, but basically when you have an open source model, you have control on your model. So what the model returns is not a word every time, it's probability distributions over all the possible tokens. And so let's say you have an evaluation data set, which is basically how they train it, being like, for this prompt, I expect this answer. If you use a closed source API, you will just get a sample answer. So you cannot really compare the two of them because, of course, the word will be different, even if it's semantically similar. When you have an open source model, every time you're generating a new answer, the token which you specified in your ground truth will actually appear somewhere in the probability distribution. So from where it appears, you can then build the loss, etc., and get an error. Can we get a last answer for this guy? I skipped.
Now, it's great that you are using Airflow and you love the tool, but how lazy is Airflow to be able, because you are updating something in Ocean, for example.
Yes.
You are triggering Airflow to update all the system, right?
Yes.
So you have Airflow like every 5 minutes, 1 minute.
No, basically we have a problem is that the Notion API is insanely slow. So we only run it twice. We only run it twice a week because we run it like we have 10 parallel workflows, one for each workspace. And for some workspace, just to crawl, and we make it kind of the most efficient way possible. And just to crawl the workspace and find changes, it can take up to 2 days.
And for every workspace, you have different database, or you are mixing?
No, I have the same database, but
Same database with
I use different workflows because just to make it faster and to parallelize the whole thing, because crawling the Notion workspaces is very, very long.
Okay, so different.
Noe will be around afterwards
Yeah.
for a bit, so you can pick his brains then. Just before we head off, I think Matt has a...
Yeah, so thanks, Noe. Amazing.
Thank you very much.
Super interesting.